All right. We're running out of time. We're right here today. We have 2 weeks. Then we have Thanksgiving. Then we have another week. And then we have finals. And these are finals. But we're supposed to show up in classes both days. If worst case to worst, then this one will be a test day. So you guys take tests and catch up everything. If we need to, we may use this as a lecture day. I mean, I'll be here or lecturing wherever I am, but we may have to have a lecture. All depends on where we are. But we finished chapter 4. So all we have left is chapter 5. Chapter 5 deals with chapter 2, section 3, section 1, section 2, section 3, section 4. I think it only has 4 sections in it. And then chapter 6, we only have 2 sections in there. And if we do chapter 7, 8, and 9, or 7 and 8, that comes later on. But I don't know if, I mean, it's there. If we don't get to it, we don't get to it. I'm not, but as long as we get to chapter 6, that's the only thing I'm really worried about. All right, what these are, we're going to do is actually, we're going to do chapter 4 today, section 6. We're going to do with inequalities. I'm pretty sure we talked about rational equations last time. We had to, we talked about asymptotes. So we'll just finish up chapter 4 and start the first part of chapter 5. Chapter 5 will be a lot easier in chapter 4. It deals with logarithms and exponents. So we're going to learn both of those rules. Chapter 6 teaches you how to solve what's called systems of equations. Substitution, elimination, graphing, and then using matrices. So we have a lot of time, a lot of stuff, so I'm not too worried about it all. So let's look at this. Chapter 4, section 6. Polynomial and rational inequalities. All right, so we'll look at polynomials first. Polynomial inequalities. Here's the rule here. Must be set to 0. So move everything to one side. And we're only dealing with inequalities, not solving polynomials, which makes it a lot easier. Solving inequalities Since we set the polynomial and rational equations equal to 0, all we're looking for are intervals of the domain that satisfy the inequality condition. Since we're dealing with polynomials and rational equations, we set them equal to 0. All we're looking for are intervals of the domain that satisfy the condition. So what does that mean? Well, it's even easier than that. Let's say we had a polynomial. A polynomial is less than 0. What this is telling us once we find the zeros, the intercepts, these are the intercepts or the zeros. So let's pretend the graph looks like this. So this is our polynomial. That's our P of X. What we're looking for here, since this is our condition, we're looking for the polynomial less than 0. So which part of these graphs, which intervals are we interested in? Yeah, actually, anything below the x-axis is what we want. Since it's below 0, we want anything that's negative, anything below the x-axis. So if we have the graph, we just look where it's below 0 and state the domain. So the domain here is from where to where? From negative infinity. Yeah, from negative infinity to x1. Since these are below the x-axis, that satisfies the condition. And also between x2 and x3. Make sense? So, you won't always have the graph. You will have the polynomial, but once you find the x-intercepts, the zeros, we call these x-intercepts, we call those critical values. What's that? The x-intercepts and zeros. Those are the reason they're called critical values is because they tell us where the boundaries begin and end for each domain. So what we do is we just take some values that are not on the line, not those intercepts, and plug them inside the equation. We take some values that are not those, plug them in the equation, and see which ones give me a negative answer. I only want to keep the ones that give me a negative answer. If it's a positive answer, I don't want it. If it's a negative, it's good. If it's positive, I don't want it. So let's see what this means. Let's do a simple example first. So in the first one, okay, there. Oh, remember it said it has to be equal to 0. You have to tell me the 0 has to be one side, because I'm only looking for the x values that makes this function positive. I only want the x values that make my polynomial greater than 0. Positive. So the first thing we do, we have it equal 0. See if we can solve for the intercepts. We have x and x. And we have opposite signs. One's positive, one's negative. The bigger one is negative. What times what is 14 when you subtract them, you get 5? What times what is 14 when you subtract them, you get 5? 2 and 7. Very good. Because 2 times 7 is 14. 7 minus 2 is 5. Because they have to be opposite signs. So since it's negative, the 7 goes here and the 2 goes there. So here's my domain. What are my critical values? Nope. Take these, set them equal to 0. You want the intercepts. So it's -2 and +7. So it goes from -infinity to +infinity. Now, since this is a strictly greater than, doesn't equal to, these are open circles. I cannot use those at the end. So now, do I want my answers to be above or below the x-axis? What does it say? I'm looking for all polynomials greater than 0. Are these positive or negatives? Greater than 0? Okay. Yeah, if here's 0, greater than is positive. So we only want values of x that makes this positive. Well, so this is how we do it. So pick some values that are not here, like 0. No, I'd say -5, 0, and 10. So since I have my x-intercepts, I pick values that are inside these domains, these intervals. So I'll try the first one, -5. I'm using this equation. So I have -5 plus 2, -5 minus 7. -5 minus 2 is -3. -5 minus 7 is -12. I don't care about the number. All I need to know is it positive or negative. Is this answer going to be positive or negative? Negative times negative is a positive. And positive is greater than 0, so this is a good number. That means any number on this side of -2 will be above the graph. Let's try 0. 0 plus 2, 0 minus 7. 2 times -7 is 2 times negative. Is that so? It's negative. Is that greater than 0? No, so that's not good. So we cannot use anything there. And then we'll just use 10. 10 plus 2, 10 minus 7. I don't, again, the numbers are not important. All I want to know if it's positive or negative. This one's positive. This one's positive. Yep. So this one's good. Because this thing tells me I only want the x values that are above 0, above the x-axis. So my solution is where? It's in the domain of -infinity to -2, unioned with 7 to positive infinity. That's my solution. Because if we drew the graph, at -2 and 7, it's a parabola, it's positive. We only want these sides since it's greater than 0. We want all our answers to be positive. That's what that says. Let's do some more examples. X squared plus 3x minus 5 less than equal to x plus 3. So we have to do what first? Yep, you have to have 0 on one side. So we have to move this stuff over. Subtract x, subtract 3. So we have x squared. 3 minus 1 is 2. -5, -3 is -8. So looking at this, do I want above or below the x-axis?
Below.
Yeah, because it's less than 0. I only want the x values that give me a negative answer. So let's factor this one out. So x and x, opposite signs, positive, negative, and the bigger one has to be positive. So what times what is 8 when you subtract me at 2? 4 and 2. So what are my x-intercepts? It's always the opposite signs.
Four and positive.
Are they open or closed circles? It's closed because I can make it equal. So in other words, I can use the -4 and 2 in my solutions. So remember, these are my critical values. So I pick numbers between -infinity and -4. So let's try -5. That's one of my values. Let's try 0. And let's try +5. And we'll use this factored form here. So at -5. -5 plus 4 minus 2. Is it less than equal to 0? So it's -5 plus 4 is a negative answer. Negative is negative. So that's positive. So I can't use that. So next one I use 0. 0 plus 4, 0 minus 2. So it's positive times negative. It's a negative. So that one works. So I can use those numbers. And then 5 plus 4, 5 minus 2. 5 plus 4 is a positive number. 5 minus 2 is a positive 3. Positive times positive is, so is positive less than 0? No. So the only part we can use is here in the middle. So my solution is at -4, 2. That's the only part I can use. You have to look at the picture you drew. That's the reason we drew the picture. We look at, okay, here are my critical values. Let's look at this first interval. Is it satisfy conditions? No. So I can't use that. Does this one? Yes, it gives me a negative answer. I can use it. Let's try another one. X squared plus 4x plus 7 is greater than or equal to 5x plus 9. So the first thing you have to do,
Placing the move on one side, so -5 minus 4 and -9 minus 7.
very good.
So we do with one,
Five is bigger than 4, it's negative. 5 minus 4 is 1. 9, 7, 9 is bigger, so it's negative. 9 minus 7 is 2. So if we can factor it, since it's in opposite signs, the bigger number gets a negative. What times what is 2? When you subtract it, you get 1. 2 and 1. So negative gets a 2.
So even if both of them are negative, is that negative one positive, one negative?
That's why we always look at the second sign first. If the only way this one could be negative is if they're opposite signs. So if the second sign's a minus, the first sign tells you which number, the bigger number gets that sign. So what are my x-intercepts? Right, -1 and 2. Open or close circles? Yeah, close. So we only want the numbers that make it positive or negative. Why? Because we want this equation is greater than or equal to 0. This number has to be greater than 0. Well, no, because that's what it's saying. It says whatever I put here has to be greater than 0, has to be positive. I only want the positive answers. So let's plug in some values that are not the critical values. Let's try -5, 0, and 5 in this case again. And plug them in there. So we have -5 plus 1, -5 minus 2. -5 plus 1 is negative, negative, negative. Negative times negative is a positive. Is positive greater than 0? Yes, so that works. So we can use that. Zero plus 1, 0 minus 2, is that greater than 0? Positive, negative. Is a negative number greater than 0? No. And then I use the 5. 5 plus 1, 5 minus 2. Positive. 5 minus 2 is a positive. Again, all I want is the ones that give me positive. So it's the first and last intervals. No. The first interval goes from -infinity to -1. And the last interval goes from 2 to infinity. You have to use the critical values. Those are those are your intercepts. All right, let's try a little bit bigger one. Mm-hmm. So what method are we going to use here? We learned a whole bunch of them, so we use any of them. We want to know what the x-intercepts are. What did we do last class? We went through an entire example how to do this stuff. We'll need to use synthetic division at the end, but what we have to do, we can use here, we can first determine the number of positives and negatives. We use Renee's Descartes rule of signs. Number of positive and negative solutions. Remember how we do that? So we're looking for the positives in this one. Number of sign changes. Positive, positive, nope. Positive to negative is 1. So we'll have 1 positive answer. How do we find the negative solutions? You change x to negative x. So what you really do is, if it has an odd exponent, change the sign in front of it. That's all it's telling you to do. So only change the signs of the odd exponents. Because if I put a negative x in there, if it's even, it cancels. It just says positive, it doesn't change. Only ones that change are the odd exponents. So how many sign changes are here? 1, 1. So it's for negative, we have 2 or 0. Negative solutions. Why is it 2 or 0? Because if one of them is imaginary, then they have to come in conjugate pairs. We have to have the 3 plus I, 3 minus I. It has to come in conjugate pairs. So we know that we're going to have 1 positive and probably 2 negatives. So what are they? Then we have to use what's called the rational zero. Remember, that was a plus or minus P over Q. So the last number goes on top. And the leading coefficient goes on the bottom. This is Q and this is P. So it's either 1 or 3 over 1. Plus or minus 1 over 1. Plus or minus 3 over 1. So here are our possible answers. So what do we do with them? Then we use synthetic division, right? And we look at positive 1 and negative 1. And inside here, I only put the coefficients 1, 3, negative 1, negative 3. 1, 3, negative 1, negative 3. Bring down the first term. Multiply and add. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. 4 minus 1 is 3. 1 times 3 is 3. 3 minus 3 is 0. So, you know, x equals 1 is a solution. Right, so now all we have to do is look at this possibility. So that's 1, 4, 3. This is my constant. This is my x term. And this is x squared. So can we factor this out? X and x. The second sign's a plus. And they're both going to be pluses since the first one's plus. What times what is 3? When you add them, you get 4. 1 and 3. So the solutions are -1, -3. So these are my x-intercepts. So it's at -3, -1. Are they open or closed circles? They're closed because the original equation is greater than or equal to. Since we know the x-intercepts, we know the factors. Since this is x equals 1, we subtract 1 from both sides, and that's our factor. X minus 1 is a factor. Then x plus 1 is a factor. X plus 3 is a factor. I need to have those because I need to have my equation. It's going to be greater than or equal to 0. Everybody follow me so far, what I'm doing? So I found my critical values. Now what do? I pick some, exactly, I pick some points. Between -3 and -3, so I put, that's it, -5. Between -3 and -1, I put -2. -1 and 1, I put 0. Between 1 and infinity, I put 2. So these are my test values. Do I want them to be above or below? You want positive or negative answers? Yeah, because it says has to be greater than 0. So I want positive answers. So the only ones that give me positive will be my solution. So put -5 in here. So I have -5 minus 1, -5 plus 1, -5 plus 3. So that's a negative. That's a negative. That's a negative. So negative times negative times negative is a negative. Is a negative answer greater than 0? No, so that's not going to work. Let's try it. -2. -2 minus 1. -2 plus 1. -2 plus 3. Is that greater than 0? So negative. -2 plus 1 is negative. -2 plus 3 is a positive. Negative times negative is positive times positive. So that one works. If you want to, you go and put numbers, but again, numbers are irrelevant because I'm interested in is positive or negative. So -2, this one inside here works. Let's try 0. 0 minus 1, 0 plus 1, 0 plus 3. Is that positive? 0 minus 1 is -1, +1, +3. Negative and positive is negative, and positive is negative. So negative is not greater than 0, so I can't use 0. Okay, you want me to use numbers instead of just signs? Would that be easier for you? Or are you okay with this? So I could use 0 minus 1 is -1, 0 plus 1 is 1. So -1 times +1 is -1. -1 times 3 is -3. Is -3 greater than 0? No, so that doesn't work. Same thing with 2. So 2 minus 1, 2 plus 1, 2 plus 3. Is that greater than or equal to 0? 2 minus 1 is 1. 2 plus 1 is 3. 2 plus 3 is 5. Is that greater than 0? 1 times 3 is 3. 3 times 5 is 15. 15 is greater than 0. So that all those numbers there work. So what's my solution?
Like negative 2,
I look at type -3 to -1, and then from +1 to infinity. Well, let's look at this thing also. Since we found the x-intercepts, since we found the factors, we know these x-intercepts. What do we notice also about the graph? About the function itself? So we know the x-intercepts are at x minus 1, x plus 1, x plus 3. So we know the x-intercepts are at -3, -1, and then +1. What do we notice about the shape of this curve? If the degree is 3, what's it going to look like?
right?
Well, they all go up, or they all go down. So what is degree 3? What does a degree 3 polynomial look like? Too many bubbles. What's that? Yes. We talked about this during the library of functions. And when we graphed these things, we also spent a whole section about if it's a degree 3 and if A is positive. We even made this little chart. If n is even, or if n is odd, if A is positive, or if A is negative. Remember that chart? This we did leading coefficient tests. If n is even, that means both ends point the same direction. If A is positive, then they both point up. If A is negative, they both point down. So if the degree is even, then both ends point the same direction. If n is odd, then they point opposite directions. if the leading coefficient, this is A right here. If A is positive, then the left side goes down, the right side goes up. And if A is negative, left side goes up, right side goes down. So in our example, we have degree 3. So n is odd, A is positive, odd and positive. So we know that the end behavior. So what we know for sure is both ends point different directions. What else do we know? Well, we know that the multiplicity of each of these factors is odd. Which means what? If the multiplicity is odd, what happens to the graph at that point? It crosses. Since the multiplicity of each of these x-intercepts are odd, that means the graph, it doesn't bounce at that point. If the multiplicity is even, it bounces at that point. But since it's odd, it crosses. So our graph will look something like this. We wanted to know, when is it positive? When is it greater than 0? Right here and right here. So it's between -3 and -1. And from 1 to infinity. Which is the same thing we just worked out a second ago. You see, there's a lot of stuff here you guys have to memorize. And there was another way you could solve it. Since we have 4 terms, we can use the grouping technique. We put, since there's a minus in the middle, include that. Let's use grouping. You should have. That would have been a perfect guess. So in the first one, what do they have in common? They both have 2 x's. So if I take out 2 x's, what am I left with? X plus 3. In the second one, they both have a negative. So that means I change the signs there. What number is after this negative sign? Yeah, if there's no number, it's a 1 automatically. So whatever's inside the parentheses, that gets over here, and the coefficients go in the next parenthesis. Oh, this is 0. X squared minus 1. Can we factor that one out? It's a difference. Are they both squared terms? What's 1 squared? 1. So yeah, x squared minus 1 is the same thing as x squared minus 1 squared. So it's a difference of 2 squares. Because it's a difference of 2 squares, I can factor that out. You see all these rules, the stuff that we've been doing? And unless you stay current with it, it's just going to mean nothing to you. You have to do the homework. You have to stay current with it. This puts us where we are. Our solutions, -3, -1, +1. And we have our graph. We have everything else we need. Let me find another. Oh, here's another one. This one may get your confidence back up. There. Let's get that confidence going. What can you do with this one? Do what? So what does that mean? They both have an x in common. I can factor out an x. If I take out one x, I have x squared minus 1. Remember, whenever you factor something out, divide by it, that tells you what goes inside the parentheses. Because a lot of people forget that 1 right there. X squared minus 1 is the same thing as x squared minus 1 squared. It's the difference of 2 squares. So my x-intercepts are where? So this is -1. This is +1. What about this one? 0. If you ever see an x by itself, that's one that people overlook. Since there's x on both of these, if x is 0, the whole thing's 0. Again, same thing. What's the graph going to look like? What's the degree? Degree is 3. Since the degree is 4, is A positive or negative? You're asking me. This is 1. That's A. It's positive. It's +1. So A is positive. The degree is 3. So what do we know about the graph? What's the end behavior tell us? That means end behavior. I just drew the graph for you. Yes, one goes down, one goes up, opposite directions. Since it's positive, this end goes up, this end goes down, right? And since they're odd, they're all x multiplicity of 1, they all cross. We want it above or below the x-axis. Why? Yeah, because I want to be greater than 0. So I only want the x's that are above 0. So my answers, are they open or closed circles on there? They're all open. There's no. Okay, so -1 to 0 unioned with 1 to infinity. There's your solution. If you understand the graphing techniques, it's a lot easier. If you don't, then you have to do is pick some numbers between theirs and plug them in. Again, you don't have to draw the graph, but know what the shape looks like. Since you know the x-intercepts, what happens at the end? And you know the multiplicities. Do they bounce or do they cross? All right. Okay, so that's enough practice for those. We'll come back to those later if you need to. Let's look at rational inequalities. Rational inequalities. What does that mean? What does rational mean? Fractions. Because ratio, the first value is ratio, means fraction. So what it means. Same with the polynomials. You have to have 0 on one side, everything else moved over to one side. Okay. Move everything to one side. In other words, set equal to 0. Set the numerator equal to 0. Set the denominator equal to 0 and solve. These two numbers here are your critical values. So we have 3x is equal to 0. So x is equal to, divide both sides by 3. Shows one of my critical values. And the second one, I set the denominator. This is the numerator. This is the denominator. X equals -6. Now, why do I set both of those equal to 0? What are they going to find for me?
We have to do that.
What's that? Those are my critical values. But why are they important? What am I using them for? So the first one, we have 0, and then we have -6. The only way you can find the x-intercept of a fraction is by set the top equal to 0. This is my x-intercept. Now, is it an open or closed circle? Can I use it or can I not use it? Well, you can't, you have to look at the original question. Can the equation equal 0? No, since there's no line, I can't use it. So at 0, I cannot use that number. I can only use the top number being 0 if there's an equal sign. Now the bottom number. When you set the bottom number equal to 0, that finds your asymptotes. Your vertical asymptote. This number you can never use. The asymptote, by definition, is a restriction to your domain. In other words, what would happen if I plugged in -6 in my equation? What would I get? If I put -6 in the equation, what would happen? That's it. Let's see. Our equation is 3x over x plus 6. If I put a -6 in place of x, so 3 times -6 is -18 on top. -6 plus 6 is 0. You cannot have a 0 on the bottom. That's why it's an asymptote. You cannot use that number. So once we said the top and bottom equals 0, if it has a line underneath the inequality on the top, if it does, then it's a closed circle. If it doesn't, it's an open circle. On the bottom numbers, it'll never be used. That's an asymptote. So now we pick values like we did earlier. Do we want them to be above or below the x-axis?
Below.
Are you asking or telling me?
Going down,
No. Well, because it says this number is less than 0.
oh, so
We only want values that make this thing negative. So we're going to be using this equation, 3x over x plus 6. We want it to be negative. So we use -10. 3 times -10. -10 plus 6. Positive negatives are negative. 3 times 10 is 30, so it's -30. -10 plus 6 is -4. Negative and negative is a positive. Will positive work? Nope, has to be negative, so I can't use it. So that's not going to work. Let's try -2. 3 times -2. -2 plus 6. 3 times is -6. 6 minus 2 is 4. It's -3 over 2. So will a negative answer work? Yes, because I want a negative answer. So that one's going to work. Let's try 1. 3 times 1. 1 plus 6. 3 over 7. Is 3 over 7 less than 0?
no.
Nope. So my only solution here is from -6 to 0. Let's do some more. Make this, is it sinking in just a little bit? 1 over x plus 4. It's set equal to 0. Check. Now we set the top and bottom equal to 0. The top you can't set equal to 0. So all I gotta do is set the bottom equal to 0. So we only have one critical value, is that -4. Open or close circle?
Open, but it's going.
It's open because it has on the bottom, we can't use it. There is no going to, it's just On this, we're setting it, we're finding the values we cannot use. Since this is on the bottom, we can't use it. It's an asymptote. So now let's check the left numbers. Let's try -10 and then 0. 1 over -10 plus 4. 1 over -6. Is 1 over -6 greater than 0?
Well, yeah. Well, no, it's not, because it's negative, right?
You're telling me.
Negative plus negative.
Because it's negative. It's negative, so this is not going to work. It's not greater than 0. 1 over 0 plus 4. 1 over 4. Is 1 over 4 greater than 0? Yes. So my solution is from -4 to infinity. All right, let's try a bigger one this time. We haven't worked one of these out yet, so you won't see it in your notes. What's the first step? What does it have to be set to? So we have to subtract 1 from both sides. So I subtracted 1 from both sides. I have 2 fractions here now. I need to have a common denominator. That's my only denominator. So 2x minus 4, 2x minus 4. Since I have a common denominator, I'll just worry about the top. Let's go ahead and work the first parenthesis. I don't need it. I could drop it. X plus 1. That one here, I could drop it. It's a no coefficient. This one is a minus sign, so I'd change the signs of everybody inside there. So it becomes minus 2x plus 4 fix the top. X minus 2x. So this is a positive 1, negative 2. 2 minus 1, so it's negative x. 1 plus 4 is 5. All right, now we have 0. We have one equation and a 0. So the first thing, set the top equal to 0. n equals 5, x equals 5, I mean. Set the denominator equals 0. 2x minus 4 equals 0. 2x equals 4, divide by 2. X equals 2. Very good. Now, what do we do with those guys? Those are my critical values. The numerator, can it equal 5? In other words, if there's an equal sign here, then I can use that numerator set equals 0. So this is a closed circle. And the denominator is always open. You can never make the bottom equal. So this, the only thing that changes on the top because of that. If there's no line, that would have been open. Now let's pick some values. 0, 3, 10. We're going to be using this equation. So we're using 0. 0 plus 5. 2 times 0 minus 4. 0, so negative 5 over 4, 5 negative 4. Is that less than or equal to 0? Yes, because it's negative, so we can use that number. Let's try 3. Negative 3 plus 5. 2 times 3 minus 4. Negative 3 plus 5 is positive 2. 2 times 3 is 6. 6 minus 4 is 2. 2 over 2 is 1. Is 1 less than equal to negative 0? No. So we can't use that. And 10. 10 plus, negative 10 plus 5. 2 times 10 minus 4. Negative 10 plus 5 is negative 5. 20 minus 4 is 16. Negative 5 over 16 is less than a 0? Yes. So my solutions are from negative infinity to 2, unioned with 5 to positive infinity. And it's a bracket on the 5, parenthesis on the 2. To another one. X plus 1, x minus 2 is greater than equal to 3. The first thing you have to do is move the 3. So we have x plus 1, x minus 2, minus 3, greater than or equal to 0. This is 3 is 3 over 1. I have to get common denominator. So the LCD is x minus 2.
Yeah.
So I have to do x minus 2 top and bottom here. So I have x plus 1 over x minus 2. 3 times x minus 2 over x minus 2 greater than or equal to 0. Since I have a common denominator, all I got to do is worry about the top. I got to fix the top. X plus 1. Negative 3 times x is negative 3x. Negative and negative makes it positive. 3 times 2 is 6. Combine like terms. Negative 3x plus 1x is negative 2x. 6 plus 1 is 7. Now I set the numerator. And the denominator equal to 0. So x equals 7 divided by 2. X equals 2. This is 3 1/2. Now wait as long as I could. We haven't done much. We just finished up. We moved the 3 over. Got a common denominator. Because the x minus 2 is the common denominator. So I put a 3 over 1, so it's common denominator. So I just worry about the top now. X plus 1 minus that. Fix all that stuff up on top. And that's where I am now. So these are our 2 critical values. What do we do with them? Can we use the 3 1/2? Why? Because that's the numerator. It can equal 0. So this is what makes the top equal 0. So yes, we can use that. So it's a solid dot there. And the bottom, the denominator, we can never use. So that's an open circle. And there's the equation, or let's see, we'll use that equation. Pick some critical values. So less than 2, if we can use, always use 0. Between 2 and 3 1/2, let's use 3. And let's use 5. So do we want numbers to be bigger than or less than 0?
Bigger than.
Yeah, because the answer has to be greater than equal to 0. So let's plug in 0. So we have on top that 0. So we have 7 over -2. Is that greater than 0? No, because it's negative. So we can't use that. How about 3? -2 times 3 plus 7. 3 minus 2. -6 plus 7. 3 minus 2, so it's 1 over 1 is 1. Is 1 greater than or equal to 0? Yes. So we can use that one. So we can use that domain. Let's try 5. -2 times 5 plus 7. 5 minus 2. -10 plus 7 over 3. So it's -3 over 3 is -1. Is -1 greater than or equal to 0? No. So our solution is that. Pretty straightforward. A lot of moving parts, yes, but it's the same moving parts over and over and over. Let's try another one. Let's try this one with 2 fractions on both sides. Ooh. Let's try this one. Well, it has to have 0 on one side. No, because these are equations. They have to stay together. So let's subtract this one. Let's subtract x minus 8 over x minus 5 from both sides. So we have x plus 6 over x minus 2 minus x minus 8, x minus 5. Greater than, those cancel, 0. Now what do you got to do? LCD. This one has an x minus 2 on the bottom. This one needs an x minus 2, top and bottom. This one has an x minus 5. This one needs an x minus 5, top and bottom. Why do I multiply top and bottom by the same thing? What is x minus 5 divided by x minus 5? 1.
Oh.
So when I multiply, all I'm doing is I'm multiplying by 1, so it looks the same. I'm multiplying both of these numbers by 1 so that the denominators are x minus 2, x minus 5s. I'm changing the way they look, not their numbers. So this one is x plus 6, x minus 5, minus x minus 8, x minus 2. So since I have a common denominator, I just have to fix the top. I have to multiply these two together and then combine them. So in this first one, this first parenthesis, x times x is x squared. X times -5 is -5x. Positive 6x. -30. The same thing here, x squared. -2x. -8x. Positive 16. Combine like terms inside there. We have x squared, -5x plus 6x is a positive x. Minus 30. -2x minus 8x is -10x. Plus 16. So far, so good. I mean, I haven't done anything difficult really yet. I'm just combining. I did the foiling up here. Now I have to combine them all. So in the top left one, I can just drop the parentheses there. Since there's no coefficient. So I have x squared plus x minus 30. This negative changes everybody's sign in the second one. So minus x squared plus 10x minus 16. Combine like terms on top. X squared minus x squared cancels. 1x plus 10x is 11x. -30, -16 is -46. So there's my equation. Now what do I do? Yeah, I've taken top and bottom, set them equal to 0. So I have the numerator is 11x minus 46, set that equal to 0. So 11x equals 46 divided by 11. X is 46 over 11 over 4 and 2/11. And my denominators, x minus 2 equals 0, so x equals 2. X minus 5 equals 0, x equals 5. So these are my critical values. Are they going to be open or closed circles? Or which one's which? What's that? Well, the bottom is always open circle. Can the top be open circle or closed circle? Is there a line underneath it? No, so it's an open circle. It can never equal 0. So what we have here is at 2, it's an open circle. 4 to 11th, that's an open circle. And 5, that's an open circle. Now we have to plug and play inside this equation. We only want positive answers. So what numbers do you want to pick? Remember, these are critical values. Between negative infinity and 2, what's the easiest number? 0. If you can use 0, always use 0. Because for that one, anything that has an x, I just throw it away. So I have negative 46, negative 2, negative 5. Since there's 3 negatives, the answer is going to be negative. Is negative number bigger than 0? Remember, it has to be, the whole answer has to be positive. The top is negative 46 divided by negative 2, negative 5. So negative, negative, and negative makes it a negative answer. Negative is not bigger than 45, or negative not bigger than 0, so I can't use that number. Let's use 3. 11 times 3 minus 46. 3 minus 2. 3 minus 5. Is that greater than 0? So 11 times 3 is 33. 33, yeah, 33 minus 46 is negative 13, right? That's a positive 1. That's a positive, that's a negative 2. So we have negative 13 over negative 2. The answer is positive. So that one works. Because the negatives cancel. So we can use this interval. .5. So let's see here. 11 times 4.5 minus 46. 4.5 minus 2. 4.5 minus 5. Is that greater than 0? That's 49.5 minus 46 is 3.5. 4.5 minus 2 is a positive number. 4.5 minus 5 is a negative number. So positive, positive, negative makes it a negative. Is negative number bigger than 0? No. See, the value itself is not that important. I just want to know if it's above or below the x-axis. So we can't use that. Let's use something bigger. Let's try 10. Bigger than 5. 11 times 10 minus 46. 10 minus 2. 10 minus 5. 110 minus 40. That's a positive. That's a positive. That's a positive. So they're all positive. It's greater than 0. So it works. So what's my solution? My critical values are 2, 4 to 11ths. Those are parentheses. Union 5 to So that's my answer. Let's do another one. I can see you guys want to do another one. No objections? X minus 3 over X plus 4 is greater than equal to X plus 2, X minus 5. All right, so first thing I do, move this monstrosity over there by subtracting it. I'm gonna move it over. Next step. You need a common denominator. This one has an X plus 4. This one needs an X plus 4, top and bottom. This one has an X minus 5. So this one needs an X minus 5, top and bottom. So we know we have our common denominator of X plus 4, X minus 5. Now on top, we have X minus 3 times X minus 5 minus X plus 2, X plus 4. Don't ever multiply your bottoms. Leave your bottom one the way they are so you see if anything cancels out. Much easier. So we have X plus 4 on the bottom, X minus 5. So X times X is X squared, negative 5X, negative 3X, negative and negative is a positive, 3 times 5 is 15. Now, X times X is X squared. Positive is positive 4X, positive 2X, positive 8. Just do the FOIL technique there. The first prints are combined like terms. So negative 5, negative 3 is negative 8. So I have X squared minus 8X plus 15. Four X plus 2X is plus 6X plus 8. Let's get rid of the parentheses on top. On the bottom, we have X plus 4, X minus 5. So in the first parentheses, I don't need it because there's no coefficient. And the second one distributes. Sure, it just changes everybody's sign inside there, basically what was going to happen. Combine like terms. So x squared minus x squared cancels. Negative 8x minus 6 is negative 14x. 15 minus 8 is positive 7. So I simplified, moved everything over, simplified it. Now I could do the numerator, denominator, set that equals 0 on my critical values. Set the top number equal to 0 and the two bottom ones. So I set the numerator, negative 14x plus 7, set that equal to 0. So add 14x to both sides. 7 equals 14x. Divide by 14. 1/2 equals x. Here's my first critical value. My denominators, x plus 4 equals 0, so x equals negative 4. And then x minus 5 equals 0. X equals 5. All right. So there's my equation. So my critical values are at 1/2, negative 4, and 5. So are they open or closed circles? What about negative 4? Why?
No, I'm on the bottom. Okay. That's the problem.
It- It's open because it's the denominator. Remember, the denominator can never equal 0. So the 4 and the 5 have to be open. Since there's a line underneath it, the top number, the numerator could be a solid dot, and that's that. All right, what values are we going to pick to test? Between negative infinity and negative 4. Try negative 10. Now here we could try 0. We try 2 and 10. But I'll also show you a shortcut at this point. We've done enough. We see if we see a pattern. So let's try negative 10 inside this equation. We want it to be positive or negative. Right, because it says this number is greater than 0. So it has to, we're looking for positive answers only. So negative 14 times negative 10 plus 7. Negative 10 plus 4. Negative 10 minus 5. Negative is a positive. 140 times 7, 147. So this is negative 6, negative 15, negative. So it's positive, it's greater than 0. Check. Since it's greater than 0, we can use it. So this will be one of our terms. At this stage, without doing the rest of them, I'm gonna say the next one, this is my guess. I'm gonna say the next one is gonna be this one. Let's work it out. Let's find out. So let's try 0. -14 times 0 plus 7. 0 plus 4, 0 minus 5. So it's +7, +4, -5. Only one negative, the whole thing's negative. Is it greater than 0? No, so we can't use that. Let's try +2. -14 times 2 plus 7. 2 plus 4. 2 minus 5. -28 plus 7. 6. -3. -21. Positive. Since the two negatives are there, they cancel. So it's positive greater than 0. So it works. And since that one works, that one doesn't, this one can't work. If you notice on the past 3 or 4 we did, you can never have two answers that are next to each other. Because of the graphs, they either go up or down, above or below. So once you find this one, I know the next one can't be right. And this one has to be right. And this one can't. The only way that could change is if I have a multiplicity that's even. Let me show you. If my factors were these. So I know it's x plus 3, x plus 1, x minus 2 squared. So what if I said I only want less than 0? So my critical values are at -3, -1, and 2. What's the degree of this polynomial? Count the multiplicities. 2 plus 1 plus 1 is 4. Basically, it's the number of x's we have. We have 4 x's, so it's 4. Which means that both ends have to go the same direction. Let's see what happens here. At -3 and -1, they're both 1, so they cross. But at 2, it bounces. So let me see. So it won't be positive. So that means the only way this is going to be positive is if this one's true and that one's true. So that's the only time it ever changes is if you have a multiplicity that's even, where the graph bounces at that point. Which is why we always factor it down to its smallest pieces and going further. Let's try this one. And then we'll call it a day. I know you guys' heads are hurting.
Yeah,
Right, so first step is I take this, move it over there. So I have an x minus 2 plus 1 over x. This is one equation because this is on this side. Its denominator is 1. This one has an x, this one needs an x, so I put x on top and bottom. I have a common denominator is x, so I have x minus 2 plus 1 is greater than 0. Distribute, so we have x squared minus 2x plus 1 over x. Now what do? Always factor. Can you factor the top out? So it's x and x. The second sign's a plus, which means what? They're both the same. They're both going to be the first sign. They're both going to be minuses. What times what is 1 when you add them, you get 2? One times 2 is not 1. 1 times 1 is 1. 1 plus 1 is 2.
Oh.
You are close. You got half of it right. All right. So now the next part of my scheme is I have to set the numerator and denominator equals 0. X minus 1 equals 0. X equals 1. X minus 1 equals 0. X equals 1. The denominator, x equals 0. So those are my critical values, 0 and 1. And we know that we have x minus 1 squared over x is greater than 0. What do we do now? What are we missing on our graph? Open up, yes. So at 0, can I use 0? No, because it's the denominator, so I can never use that. How about the tops? Is it open? Because there's no line, right? Yeah, for the top, if there's no line, it's automatically open. All right, so now we pick some numbers. -1, 1/2, and 2. Let's pick some easy ones. So we plug in -1 first. -1 minus 1 squared over -1. Is that positive? -1 minus 1 is -2 squared. -2 squared is 4 over -1 is -4. Is that greater than 0? No, because it's negative. Negative is not greater than 0, so that doesn't work. How about 1/2? 1/2 minus 1 squared over 1/2, is that positive? 1/2 minus 1 is 1/2, negative 1/2. Divided by 1/2. Since the negative is inside the parentheses and you square it, it cancels. So it's 1/4 divided by 1/2. Leave the top one alone, flip the bottom. And cancel. So equals positive 1/2, and that's greater than 0. So that works. So we can use that. How about 2? 2 minus 1 squared over 2. 1 squared over 2 is 1/2. So that works. Why does that work? Well, yeah, because we have a multiplicity. The graph bounces there. So our solution is from 0 to 1. And then from 1 to infinity. Why cannot equal 1? Because if it equals 1, the top is equal to 0, and it can't equal 0. It's not equal to. So because of that, we have to make these 2 steps. What do y'all think? It's a lot of moving steps. I'm not gonna lie to you about that. Just go ahead and look at that and do it step by step by step. Yeah, let's call it a day. It's almost 3 o'clock. That does it for chapter 4.